Yes, is this thing working? It is. I'm gonna have to ask you to lower the volume just a little. Can you please lower the volume of my microphone just a little bit because I'm Colombian and I talk very loudly. I cannot help it. So, good morning, everyone. Lavas or something. Yes. Thank you, thank you, thank you. I'm becoming very fluent in Lithuanian. I know how to say lavas and ačiū. That's it. That's about it. I saw in the statistics that we have people from abroad. I'm curious where everybody is coming from. Who came like from really far away? Can you please raise your hand if you think that you came from far away? Where are you from? USA, right on. How about you? Where are you coming from? Latvia, that's not far. Come on. All right. Okay, fair enough. Okay, so we have America, we have Europe. Do we have anybody from Asia? That part of Istanbul that is in Asia does not count. Okay, fair enough. Welcome, everyone. My name is Carlos Leon. I'm a strategic consultant, and currently I'm working at ING, where I'm helping them with their cultural challenges and their technological challenges as well. And one of the things that I've been working lately is in pipeline migrations, CICD pipeline migrations specifically. And during that process, I figured out that this migration process shouldn't be as hard as it was during that point. And then I thought, okay, I'm gonna summarize this and crunch it down into some slides that make kind of sense, and I'm gonna bring that to you today. And hopefully you can walk away with the knowledge that you can bring back to your own company. So if time allows, we will be able to go through the whole agenda. We're gonna be starting with the basics of CI/CD just to make sure that we're all on the same page. We're gonna be talking about the status quo of the industry regarding CI/CD. We're going to be talking about some tooling around CI/CD, some example application. We're going to be then talking about portability of CI/CD, and then we're going to have a slot for Q&A. Oh, by the way, so if you want to write down your questions, here's the Slido. Just start going there, and eventually we'll go back to that. Right, so the basics. CI/CD and agile methodologies combine in the way that CI/CD became an answer to agile. We have a software development process where we take some business requirements and we convert that into code, right? Eventually we're sitting down writing features, and we want to make sure that this feature makes it at some point to production. And we want this process to be as fast as possible and as smooth as possible. So what we see here is that we have a planning phase. Eventually we convert that into business requirements that become code that at some point get verified, packaged, then released somewhere. There is some configuration going on and some monitoring, and the whole process starts over again. Now, we saw in the industry through the years that this process, when done manually, can be both quite cumbersome, and it also can be time consuming, and most importantly, error prone, because we're humans and we make a lot of mistakes. Even when things are by the book, even when we're following instructions from the manual, we still screw up. Why? Because we're human and we're prone to error at some point, eventually. Everybody, every single one of us. So a build pipeline or a delivery pipeline, a CI/CD pipeline, will eventually look something like this, very roughly. Also, disclaimer, the examples that I'm going to be showing up here are very simplistic. I've simplified them for the sake of the talk, because otherwise it would take a lot of time to explain them and a lot of mental bandwidth to understand what is going on. So I've made it as simple as possible so that everybody can follow. So what we want after writing our code is to push that code somewhere. Nowadays people are using Git, so let's assume that we're using Git and that we commit our changes and then we push them to a repo. And eventually what we want to do is to just not do anything else. As a developer, as an operator, as a tester, I don't want to have to do anything with the machines themselves. I just want to write my code and have that just work seamlessly. So once the code has been pushed, some entity is going to pick up that code and is going to build it. It's going to run some tests against the code. This can be unit tests, functional tests as well. And then once packaged, I want that unit to be deployed to a staging environment, where afterwards we're going to be running some more tests against it. And these tests can be integration tests, or they can be smoke tests, whatever you want. And if these tests are passing, then we want to promote this deployable unit now to production. And the less human interaction there is in this pipeline, the better. Because again, if we ask for user input, there is the chance that there's going to be mistakes. Everybody following so far? Yes? Cool, thanks. So, the good thing about this process that you see back here is that it's predictable, right? Because you can see it, and it's a computer that is following the steps, not a human. And computers are really dumb, but what they're good at is following the instructions that we give them. So if we give computer instructions A, B, and C, the computer is not going to go for B, C, A, D. It's just going to go from the one instruction to the next one, to the next one, to the next one. So it's very predictable, both the input and the output. It's reproducible. Eventually, if we want to go back in time, if we give a certain input and the program hasn't changed, it will give us the same output. So this is a lot of value for the companies. There's a lot of visibility as well, because the computer needs to read these programs from somewhere, and it's not in someone's head. So we can definitely see that. And there is accountability, and less error prone, of course, because it's automated. The bad about this approach, or two of the biggest challenges that I've seen so far, is semantic versioning. And I'm really curious how everybody else is doing semantic versioning in their automated CI/CD pipelines, if at all. And I would really love if you can come to me and talk about this, how you fix this in your company. Because the current solutions that there are currently in the market or in the industry do not satisfy me completely. And the second thing is that it can get really chaotic when the pipeline is really slow. I think I'm gonna run a quick poll in the crowd to figure out who has the slowest pipeline in the crowd. Can you please raise your hands if your pipeline takes more than 10 minutes to complete? All right, keep your hands up if your pipeline takes more than 15 minutes. 20 minutes? 30 minutes? Oh my God, 1 hour? Jesus, how many? Okay, there is only one hand. How long does your pipeline take? He said 6 hours, and the next person? How many hours? What? 2 hours. So you're still winning. You have the 6 hours. So you see, it can take 6 hours for one pipeline to finish. And imagine that if you go back here, you're on the whole pipeline has been automated, right? So now you're on the part where you run some tests, and now you're deploying to production. But suddenly something failed, and now production is broken because of your release. If you're going through the pipeline, you wait 6 hours to fix the problem. So production, even though you want to fix it, it'll take you 6 hours in an automated fashion for it to finish it. So this is one of the bad things about automated pipelines. If your CI/CD pipeline takes 6 hours to finish or more, as I've seen before, then it can really get on the way rather than enable your team to move faster. So let's talk about the status quo of the industry regarding CI/CD. If I ask you what is the de facto CI/CD tool in the industry, what name would you say? Let's hear it. Jenkins. Yes, that's right. I'm pretty sure that you've worked with this before. If you've been in the industry for 10 plus years, you know Jenkins, and you love it, and you hate it. It is there, and it is here to stay. So Jenkins is not good or bad per se. It's just another product that fixes a problem in the industry, very important problem, which is automation. So the good thing about Jenkins is that it has a big community support. It's been around for a long time. Before it was Hudson, and then it became Jenkins. So it brought a lot of its ecosystem into the new version. So whenever you go on internet and you have a Jenkins problem, you can for sure find someone else that has had your problem already. And it's been fixed, hopefully. And there is a lot of documentation around it, so you can really get unstuck real quick. There is also commercial support. CloudBees is the people that write originally Jenkins, and they offer commercial support for the companies that are willing to pay. Also, a big ecosystem around plugins. So if there is one thing that needs to be automated, most likely there is a Jenkins plugin that already does that for you. So this is a good thing. So it is well known. I don't need to explain that one. And it's battle tested. So even though a lot of people hate Jenkins, the truth is it works. I know it hurts a little bit to hear it, but it works. So yeah. Now, the bad thing about Jenkins, maybe I can ask the crowd what is bad about Jenkins. What do we hate about Jenkins? Security is Java. Well, Java is not necessarily per se a bad thing. It is, but not necessarily, but okay. Anything else besides Java and being memory eager? Like you need 10 gigabytes of RAM to run a micro instance. So what? Okay, so the Groovy, okay, we're going to talk about that in a second. Yes, the Groovy DSL is also one thing that can be a good or bad thing, but okay. Right, so we have a lot of reasons why to not like Jenkins. One of them is just really eager for resources, as you were saying, but this is not naturally to Jenkins, but naturally to Java applications. But nevertheless, it is eager. It is also hard to automate. When you're setting up Jenkins, there's this concept of the initialization token. And so if your Jenkins cluster dies and you want to bring a new one up for a new environment, for example, also, then you really need to play tricks to fetch this token and then being able to set it up and then install the plugin. It's complicated. You don't want to know about this. It's stateful to the bone. If you're starting setting up your pipelines and you start installing plugins and configuring environment variables and whatnot, there is not a it stores everything in its own cluster, and if you lose that, then all your configuration is gone. So it likes to be a snowflake, Jenkins, unfortunately. So this is one of the biggest things that hurts the industry the most when it comes to Jenkins. And the extensions plugin ecosystem is also a good and a bad thing. Why? Because I'm pretty sure that most of you have had it, if you've been running Jenkins for long enough, that you have all these plugins in your setup, and suddenly you cannot upgrade to the next version of Jenkins because one plugin is holding you back, or because you upgraded and the new version is breaking the plugin. So it's really hard to keep up with the updates if your plugins are not. And if you don't know Java and you don't know how to extend them, then you're in a lot of trouble. So some of the competition that there is around Jenkins, you can see here. So there is GitLab CI, there is Drone CI, Semaphore CI, Travis CI, GoCD, and a bunch of other tools. But the thing is, in principle, they all do the same thing. They are really good at running bash scripts or anything else, but they just run things. They just run programs for you. So they pick up your code, right? As we were saying before, it builds, it tests, everything that you tell it to do against your code, it will do. And it doesn't even need to be against your code, but the idea behind the whole CICD thing is to test your code. So we're going to be looking into a sample application. Oh wow, I just got electrocuted by my computer just now. So it's we're going to imagine that we're writing a Go application, and this is just a web application. It's some API that anybody familiar with anybody not familiar with Go? Who doesn't know what? So Go is this language that Google wrote, and it's pretty cool in certain ways. And I think that one of the killer features is that you write your code and the standard library is super complete, so you don't need a lot of external dependencies to write web applications. But also, it compiles into this one binary file that contains everything that it needs to work. And you can cross-compile from one platform to the other. So if I write in Linux, I can the same program without any changes. I can compile for Windows, for BSD, for Unix, like that. So this is why I've chosen a sample Go application for this demo. Actually, it's not a demo. Lower your expectations. There is no real code behind this. But if we look into the folder structure of my program, this is more or less what it looks like. There is the main application, main.go, and then some tests, and then some README. This is completely fake, by the way. But the idea behind this is that we can look into the structure of the folder and what we're going to do against it if we were to do CICD with it. So initially, what we need to do is to build our code, right? And so the commands to build the code and to test the code and to compile and package and whatever can be anything, right? What is important is the concept. So in Go, you would build a binary with Go build. But if it is in Java, you would do Maven build or something. Or if it is a C application, you would use make. But it's not, the important thing is not how do you build the code, but just to know that there is a concept of building code. There is a concept of testing code. Everybody with me so far? I cannot really see your faces, so I don't know if you're confused or if you're engaged. I have no idea. I might as well just take off my glasses right now. So this is Jenkins, or this is how you set up some project in Jenkins. And we can see then my application is being built on this step. I've defined a bunch of steps. There's many more steps here, but the screenshot was rather cut off. So that's all right. So the first command or the first step that I want to do when I start my CICD pipeline is to build my code. I want to make sure that it's still built. So I do that with go build, and then the output of the build is going to be placed in the folder dist and on this file called app. So this is where my compiled code would be. If this succeeds, then I'm going to run tests. And in Go, this is how I run the tests for the application. And afterwards, we said, okay, after we run unit tests, we would like to promote this artifact to staging, to a staging environment. And this is my deployment strategy for this application. You can see that it's super simple. What I'm doing is I'm copying that binary file, this tab, which was built here, to some staging server on some folder. And afterwards, I am running a command on that server, which is my staging env example.org. I'm just doing a systemctl restart application. That's very simple. And afterwards, if you continue this line of thought, you would find another command that would run integration tests, and then another command that would deploy to production, and another command that would run some more sanity checks on production afterwards. So one of the problems with this approach is obviously there's a lot of manual steps. What I need to do is to go to the Jenkins UI. I need to go click create a project, and I need to start defining the steps, and I need to punch in each of the steps in there. So here, 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 here. And if my Jenkins instance is gone, then my project is also gone. So then next time I would have to reset up that. If it is one team with 5 projects, sure, I mean, tough luck. But if it is a big organization with 1,500 plus Jenkins jobs, then you don't really want to lose your Jenkins cluster at all. So that's one of the issues. The other problem is that changes are not visible, right? Because I log into the interface and I make all the changes, all the configuration changes for my pipeline, but once I save, it's not really visible who did what. And it's also not, there is not a way to know what was the previous version. So if something changed, I created a pipeline, and then at some point I come back and I see that it changed. I don't know why it changed, why somebody changed from, let's say that instead of using SCP, now here we find FTP, because 2019 we still use that. So why would anybody do that? I don't know, but the reason would be in some git log, but there's no git log on your Jenkins pipeline. So you don't know what or why or who or, right? So what? So there is a plugin for that. Nice. Of course, it's Jenkins. There is a plugin for that. I should have known better. Thank you very much. So there is no track, of course, so changes are not visible, and there's no responsibility. If somebody changed that, yeah, and it broke, and if, for example, if I change it and I break it, I can just disappear. It's like I see all the lights going off and we have red and everything is broken, and somebody say, the pipeline broke, who broke it? I can just like, I'm gonna go for some tea and ignore them and pretend that it didn't happen and that it wasn't me. So you don't want that. And the feedback loop is really, really long, because if you make a change, let's say that, okay, we're now migrating from FTP onto SSH, SCP. So we make that change, but for the change to pick up, we have to either restart the job, or we need to commit some change, push it, and wait for Jenkins to pick it up. So this feedback loop is not ideal. It's actually rather long. So let's see how we can make this change. Why are you My computer keeps on electrocuting me. There's a lot of static going on. Okay, so let's make this example portable. So yes, Jenkins Pipelines, that's what people were suggesting. I know that you were waiting for it, so this is the moment for you to shine. So what we have here is, there is a plugin in Jenkins, of course. It's called Jenkins Pipelines, and what it allows you to do is to, instead of defining your pipeline like this through the interface, what you do is that you define a Jenkins file on the root of your project, which is the one that we're seeing here, and this is groovy. And with some syntax sugar, you can define your steps, and you can call all the commands that you want. So if we look into the first steps, just ignore this first part. You don't need to understand exactly how it works. You just know that it works. It compiles. So we have a stage called build, and we're calling the go build with the same output for this tab in this path. Then we have the test stage, where we run the go test, deploy to staging, and the same we're using a CP, and then system CTL restart app. And the rest of the stages are there: test staging, smoke tests, deploy to production, sanity checks. So why is this a good idea? And why is this a big improvement? Because now we have this in our Git repo. So now we have all the traceability, we have the why, we have the who, we have the when. So this is a big win. But we can take it one step further. Because if you see, this is very Jenkins specific syntax sugar. If tomorrow we are to migrate to a different system, then we need to migrate all these commands. Well, it shouldn't be that hard though, it's just copy paste, right? But I'm gonna show you how to make this even more portable. So imagine that we have now a scripts folder with all these shell scripts here. So what these scripts are going to do is basically exactly the same that we've been doing here, but just from bash. So in our Jenkins file, instead of calling directly the commands that we want to, we just call the bash scripts that are going to do that for us. So on the first stage, the build stage, we have a scripts build.sh file, and you can imagine what it's doing inside is doing the go build-o dist app. That's what's going to happen. The same for the test, deploy to staging, test staging, and the consequent steps as well. So the big win with this approach is that now the feedback loop is way, way shorter. Because instead of having to commit and push something to the pipeline or to our repo and wait for the pipeline to pick up the change, we have a shell script that we can run locally, and we can feed all the variables that it needs. And in this way, we have reduced the feedback loop. Is that clear to everyone? Can you see that happening? Yeah? There is one question, but I'm going to wait for that until the Q&A, sorry. So now what we're going to do is to add support not only for Jenkins, but also for GitLab CI, for Travis CI. And these are the two examples that I've chosen for this talk, but you can imagine that you can extrapolate this into any CI/CD tool that you are going to use. So this is a GitLab CI configuration file. So it is on the root of my folder. It's called .gitlab-ci.yaml. If you have used GitLab before, then you're very familiar with this. It's a YAML file where you're describing all your steps and all the what you want to do, the shell part of the step. So we have a build step, which is calling the build sh shell script, test calls the test unit, deploy to staging calls deploy to staging, test staging calls the test to staging, deploy production, and so on and so forth. It's very straightforward, and we didn't have to copy paste a lot. We only had to invoke the bash scripts. And now we're adding support for Travis CI. It's way much more simplistic than the others. It's just language, the script, and then just calling all the steps that we want to. So the pros of this approach is that it's portable. So the next time that you want to add support for a new CI/CD tool, you don't need to figure out a lot of the syntax sugar that they want to offer you. The iteration loop is way, way shorter, and I think that this is the main value that there is. The productivity of the team is going to increase. The testability is going to be easier. Debugging is going to be easier. Accountability, because you are now having the scripts in your source code so you can know what changed and when and why. So you will be able to track the changes. cons of this approach is that it's hard to bootstrap, because you see, just like in Jenkins, there is also which has like a big ecosystem around plugins. There is also Azure DevOps, and now Atlassian also announced a marketplace which has plugins for history and has plugins to talk to Kubernetes and to deploy to OpenShift or to do some serverless stuff, right? So this is all very nice, and it works with the click, 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 but to automate it is really hard. That's the one part. But the most important part is that you're jumping straight into the vendor lock-in pool. Why? Because if tomorrow you want to walk away from that plugin to deploy to Kubernetes, for example, you won't be able to. You need to choose a provider that has that kind of plugin. So now, well done, you are locked into the vendor. So it is hard to bootstrap because you have to write all these steps that the plugins do for you. You have to write them yourself. So that might not be easy in the beginning. So it's an investment that your team has to do. You need to decide if there is a business value for you in there, which I believe there is. That's why I'm talking about this. So it might be time for people to learn how to bash. And it's hard to reuse community components because there is not a lot of bash plugins regarding deployment strategies so far. So that's a bit of a bummer, but that's what there is.